Yes, you can.
Myself, Dr. Sudip Chatterjee. You know that JEE Mains as well as NEET examinations are knocking your door. Today, we are going to show you some of the shortcut tricks, shortcut methods for solving some of the numericals where more than one chapters are involved. Particularly, we will focus for the numericals based upon mechanics. But remember, the shortcut tricks comes from the basic concept, must be your basic concept. It should be very, very clear. Otherwise, you cannot apply the shortcut tricks in a right way. Just one shortcut I'm just telling you for the motion or for a body moving along a straight line over a surface having friction. In that case, we can apply a shortcut trick. The acceleration of the car, it can be written in this way, equal to coefficient of friction into acceleration due to gravity. That means A equal to mu g, or otherwise coefficient of friction is the ratio of acceleration of the body and acceleration due to gravity. This one can be used as a shortcut trick for a body moving along a linear path. This one can be applicable for a body moving in a linear path. Just some of the examples we will discuss here, right from one question to another question, how the shortcut tricks can be utilized. Let's see. Suppose this one is question number 1, a very simple one, simple question. The velocity of a train suddenly decreases from 72 km per hour to 36 km per hour in 5 seconds. So what happens when the velocity of the train decreases? All of you move forward. So here, a suitcase is kept over the rack of the train. So you understand, whenever the velocity of the train will go down, when it will decrease. With all the passengers, the suitcase also will try to move forward. You have to calculate the maximum value, the limiting value of the coefficient of friction mu between the suitcase and the rack of the train, so that the suitcase will not start to move over the rack. How to do it? The velocities are given. Initial velocity of the train 72 km per hour. First of all, the methodical way, let us try. Then after we will apply the shortcut. So the initial velocity of the train given 72 km per hour, and the final velocity becomes 36 km per hour. Velocity decreases within 5 seconds. So obviously a retardation takes place in the train. So if we do it in a methodical way, let's do. So initial velocity of the train was given 72 km per hour. So you can convert it into meter per second. Just multiply it by 5 by 18. So it comes 20 meter per second. This one was the initial velocity. The final velocity of the train, it was given 36 km per hour. So to convert it into meter per second, it comes 10 meter per second. 10 meter per second. The value of time was given 5 seconds. So this one, the things which are given in your question. The value of time is given 5 seconds, initial velocity 72 km per hour, final velocity 36 km per hour. So we understand the retardation of the train A is equal to u minus v by t. So retardation, it should be negative, but we are calculating it in this way, either u minus v by t, or you can calculate it also by v minus u by t, no matter. So retardation of the train or acceleration of the train, you will get a negative acceleration in this case. So it comes 10 minus 20 divided by 5. That means 2 meter per second square. So this is the retardation with which the train is decreasing its velocity. Now, in the methodical way, what happens? The conventional way as well as methodical way, both we will show. So this one is suppose the rack of the train. This is the suitcase. So how many forces are acting over the body? You understand. The weight of the suitcase, it acts vertically downward. If the mass of the suitcase is m, weight must be mg. The inertial force, if the retardation of the train is along this positive x direction, the inertial force is acting over the train along this direction, it must be equal to ma. Now, the normal reaction force must act along the vertically upward direction, let it is n. And the force which will try to stop the movement of the body, that one is nothing but the friction. Friction always acts along the opposite direction of movement of the body. So the force which will try to stop the movement of the body along the contact surface between the body and the rack, that one is the friction force. So if the friction force balances the inertial force ma, the body will not move. So at equilibrium, all the forces will try to balance each other. That means we get at equilibrium F must be equal to ma. Friction force means we know mu into normal reaction force should be equal to ma. In this case, the normal reaction force is balancing the weight of the body. So the normal reaction force in this case is equal to weight of the body mg. It should be equal to ma. So from both sides, mass of the body will be cancelled out, and we get ultimately mu equal to a by g. The value of a, acceleration or retardation, remember, you take only the numerical value of a. It can be acceleration, can be retardation, no matter, but the value of mu never can be negative. So take only the value of retardation or acceleration. The value is 2 meter per second square. The negative symbol has come because the train was retarding. The speed of the train was decreasing. So here the value of mu will come simply a by g. So value of a is 2, value of g we can consider for simplicity 10 meter per second square. So value of g is coming 10. So mu is coming 0.2. So we have told this shortcut earlier for any moving body which one is moving along a straight line, the shortcut trick we can apply without doing the numerical. We can apply it mu equal to a by g. So by any means, by any way, you calculate the acceleration of the body or retardation of the body, divided by 10, divided by acceleration due to gravity, you will get simple. You will get the value of mu. So here the acceleration or retardation we have got 2. If you divide 2 by 10, value you are getting 0.2. So in this case, you are getting the value equal to 0.2. So without drawing the diagram, without doing the force balance, we can also solve the questions by this way. Let us come to another application. If this one is clear, let us come to another one. This one is also a very important type of question where it is given 50% power of a car is utilized to overcome the friction of the road. It's a very rough surface. So almost 50% of the power of the car is utilized to overcome the friction of the road. And the rest of the power is utilized to increase its velocity. Half of the power is utilized to overcome friction, and the next half, the other half of the power is utilized to increase its velocity. If the coefficient of friction of the road is 0.5, then you have to calculate the acceleration of the car. Remember, if you apply the shortcut, it will not take more than a second to find out the answer. What is the shortcut we have understood? Shortcut we have understood mu equal to a by g for a linear motion. Mu equal to a by g, that means a equal to mu g. This is the shortcut trick. If we apply, first let us do it by using shortcut, then we will do it by method. So a equal to mu g means it comes, value of mu is 0.5, value of g you can consider 10 meter per second square. So it comes 0.5 into 10, that means 5 meter per second square. So within a fraction of second, you can find out the answer without touching the pen. Remember, if we apply A equal to mu g, mu value is given 0.5. So multiply 0.5 by 10, you are getting the answer. Now you may ask me the question, here it is given 50% power of the car is utilized to overcome the friction. If it is not 50%, if it is 20%, 30%, 15%, then what will happen? We will come. We'll come to that types of numerical also. But before that, let us find out how does this shortcut comes. In the previous question, we have got how the shortcut came. In the previous question, yes, we have got how the shortcut came. The shortcut came by this method. So this one was the method by which the shortcut came. The acceleration we have calculated, all the forces we have balanced, all the forces which are acting over the body, we have balanced all the forces at the point of application of the forces, and after balancing all the forces, we got the value of mu in this way. Now, in this question, we have to find out the general method. Remember, power means in general. What do you mean by power? Power means rate of doing work. So algebraically we can simply write W by T. Actually it should be dW dt. Work done means it's the scalar product, or this one is the dot product between the force and displacement acting over the body. So it should be F dot D divided by time. From Newton's second law of motion, force means we know mass into acceleration. So it comes mass into acceleration into displacement divided by time. So you understand, this power is utilized to accelerate the car. This power is utilized to give the acceleration to the car. Again, so if we can write it as the power for accelerating the body. Again, the frictional power, the power which is utilized to overcome the friction, that should be equal to frictional work by time. Rate of doing work is known as power. Frictional work means friction force into displacement by time. Friction force means mu into normal reaction force into displacement by time. Normal reaction force over the car, if this one is the car, suppose weight of the car is acting along the vertically downward direction, normal reaction force must act along the upward direction, along the perpendicular direction to the surface. So this normal reaction force should balance the weight of the car. So in place of N, if we put mg, we can write, here we have applied small m. So let us write weight of the car as small mg. So mu into n, n means mg, into d divided by time. Now in your question it is given both of the powers are equal, because 50% of the power of the car is utilized to overcome the friction, and the rest of the power means another 50% of the power is utilized to increase its velocity. So just see, both of the powers, that means are 50-50. So power to accelerate the car and the power to overcome the friction, both are 50%. So this one is your 50%. This one is also 50%. So we can write both are equal to 50%, means we can write it in this way. 50% of the power is utilized to overcome the friction, and rest of the power is utilized to to increase the velocity of the car. So from this part of the power to accelerate the car, we get it is equal to MAD by T. And the power to overcome the friction, we get PF is equal to mu mgd by T. So if we equate these two parts, what we get? PA means MAD divided by T. This one is also equal to mu mgd divided by T. So after simple calculation, M d by T will be cancelled out, and we get our required shortcut technique A equal to mu G. The same A equal to mu G we have applied here to find out the answer. A equal to mu G. So value of mu, in the question it is given 0.5. Value of G we may consider as 10. So acceleration of the car we can write 5 meter per second square. Now obviously a question will come, a question must arise in your mind if the power is not 50%. In this case we have got both of the powers are equal. If it is not equal, then what will happen? If it is equal, then it is easy. We can apply simple. PA should be equal to PF. But if it is not equal, if the powers are different, let us come to another question. Here it is given 25% power of a car is utilized to overcome the friction of the road, and the rest of the power is utilized to increase its velocity. The question is same. Only the fraction of power to overcome the friction is different. It's given 25%. So from the previous question, we can see. Here in this case, we have got PA is equal to PF because it was 50%. The power to overcome the friction also was 50%. Power to increase the velocity also was 50%. So we have got 50 equal to 50. But in the next question, what we are getting? In this case, you just see power to overcome the friction is 25%. Power to overcome the friction is 25%. That means the power to increase the speed of the car, that means the power to accelerate the car, it must be 75%. Can we now write 75 equal to 25? Never. We can write it in this way, multiply 25 by 3. So we can write it in this way. It comes 3 into 25%. Yes, now both sides can be equal. So this power is to increase the velocity of the car. That means power to accelerate the car. And this power is to overcome the friction of the road. In the previous question, we have found the PA. PA means power to accelerate the car is coming MAD by T. And the power to overcome the friction is coming mu mgd by T. That means if we put in this case PA means MAD by T, and this part is mu mgd by T. Now after calculation, what you are getting? This M and D by T will be cancelled out from both sides, and we get A is equal to 3 mu G. So the basic part remains same. The basic shortcut, it remains same. Basic shortcut is for all types of linear motion. Whenever the body is moving over a surface having friction, we get A is equal to mu G. Yes, this one is the shortcut. Now, whether it will be multiplied by any number or not, that depends upon what percent of friction and what percent of other power are equating each other. So in this case, the answer will be A should be equal to 3 into mu value was given 0.5, G is given 10. That means it's coming 15 meter per second square. So we understand the basic shortcut part is A equal to mu G. For all types of motions along a linear path, basic shortcut is this. Now whether it will be A equal to mu G or A equal to n times of mu G, that depends upon what fraction of power is utilized to overcome friction and what fraction is utilized to increase its velocity. I think a very shortcut trick, a very useful and a methodical shortcut trick you have understood. But remember, before using any shortcut, your concept should be absolutely clear. Otherwise, you may face difficulties. And if your concept is absolutely clear, you can apply the shortcut and you can remodify the shortcuts in your NEET. Thank you.